Start. Here is refraction at a plane surface. Here is how the light bends. That means from one medium to another medium when it goes. And here is laws of refraction of light and expression for lateral shift. First question you can see here. Second one is here. I am going to just remind you. That you have already studied about you when you were in class 10 or 9. That is already given. I think from the class 8 too. So it is just for reminding all this. Here is first what is the refraction of a light. You know that these are important for making ray diagrams. So these are important while constructing any ray diagram related to the refraction of a light. Light rays ले के भन्छ त भन्दाखेरि the incident ray and the refracted ray and the normal at a point of incident all lie on same plane. एउटै पोइन्टमा एउटै प्लेनको चाहिँ सबै यिनीहरू इन्सिडेन्ट भएको पोइन्टमा इन्सिडेन्ट रे रिफ्लेक्टेड रे नर्मल पर्छन् भनेको छ. When light travels from the second rare medium to the denser medium, it bends toward the normal. While when it travels from the denser medium to rare medium, it bends away from the normal. भन्नुको मिनिङ लाइट रेयरबाट डेन्सरमा जाँदा नर्मलतिर बाँधिन्छ भनेपछि जब चाहिँ लाइट चाहिँ डेन्सरबाट रेयरमा जाँदा यो चाहिँ it bends toward the bends away from the normal. Here is given. This is second law of refraction. And the third law is for the pair of a medium, the ratio of a sine of an angle of incident to the ratio of a sine of a refraction is a constant and called the refractive index and is denoted by mu. You got sine I upon sine r, sine mu equal to c by v भन्ने यहाँ दिइरहेको छु. भन्नुको मिनिङ कुनै दुईटा मिडियम लाइट एक मिडियमबाट अर्को मिडियममा जाँदाखेरि जुन इन्सिडेन्ट एंगलले बनेको जुन इन्सिडेन्ट एंगलको जुन रेशियो साइन रेशियो त्यसै गरेर त्यसको रिफ्रेक्सन रेशियोको हामीले चाहिँ रेशियो लियो भने त्यो चाहिँ कन्स्ट्यान्ट हुन जान्छ. त्यो रेशियोलाई चाहिँ रिफ्र्याक्टिभ इन्डेक्स भन्छ. त्यसलाई चाहिँ म्युले डिनोट गर्छ. एक्चुअली द रिफ्र्याक्टिभ इन्डेक्स means the light how faster in any medium, how slower in any medium with respect to the velocity of light in the space. That's what it is. Refractive index, it is the unit free quantity. It is the just ratio. So it represents 1.5 means 1.5 times speed faster, 1.5 times slower. This is just comparison of light. Represent here refractive index. Next one you can see lateral shift. Lateral shift is easy one. When the light incident on any medium, then the emergent ray. This is incident ray, and its original direction is this, and it is going from the air to the glass. At that time, at this medium, this is the medium which separate air and glass. So at this point, light bend. Look at this normal, it bends toward the normal, and when the light goes out from this glass to the air again and denser to rare, it bends away. You can see this is emergent ray. This is the original direction of this incident ray, but due to the reflection, it got refracted this way toward the normal without going at its original way. So when we draw this original line of this incident ray, original direction of this incident ray, and you can see emergent ray, these two will be perpendicular. And the distance, perpendicular distance between this direction of this emergent ray and the direction of this incident ray is called lateral shift. It is denoted by d. You can see here PBQ, which is the perpendicular in between these two parallel lines. Emergent ray this one, and this is the direction of the incident ray. These two are parallel. That's why in between them there is perpendicular distance, which we call the lateral shift. Here all the phenomena you can see there in triangle ABQ. Here is sine I minus r. You can see from here, and BQ equal to sine I minus r equal to BQ upon A by B. This is P by S formula. We apply in this triangles, and same the way again we apply formula of cos cosine AB in triangle AB and 2. You can see this way T by AB. Here we apply formula B by H, and A and 2 is here I have written in the place of A and 2 is T because it is the thickness of this glass slab. And when you cross multiply and take it in left side AB, then the d by cos r is the second equation. Here b equal to AB sin I minus r equal to first equation. When we combine these two equations, then you could see, you may write this way: b equal to t sin I minus r cos r in the denominator part. Similarly, in the place of BQ, you know BQ means distance, so I write here d, and t is as it is, sin I minus sin r is as it is, cos r is as it is. This is the required expression for this lateral shift. When you gonna find how much lateral shift in any medium, then you can use this formula to find this lateral shift. This one is expression for it. When the angle of incidence becomes 90 degree, at that time we place in the place of I 90 degrees, sin 90 minus r, this is cos r, cos r is cancel, so t equal to d equal to t. That means thickness becomes equal to the lateral shift when angle of incidence becomes 90 degree. So this way we can calculate this equation 3 is the one of the expression for calculation of this lateral shift. In this way you may get this expression for this lateral shift, and these all three are the laws of refraction of light. That's all for today. Thank you for any for giving a chance to describe all this. And these are very easy. Do not take them as difficult as you think. They are very easy. These are phenomena. So if you have any confusion, please comment in this video.